Hello everyone, in this video we're going to find the value of a function if it's given this exponential function. Let's start. First of all, let me rearrange this function. So f of x is equal to, so I can rearrange the first fraction as follow. So in the numerator I can express 4 to the power of x as 2 to the power of 2x divided by, so 25 to the power of x plus 1 as 5 squared and times x plus 1. And plus, in the second fraction, let me rewrite the numerator as it is, 5 to the power of x divided by, so I can express to the power of x plus 1 as 2 to the power of x times 2. Now let me continue to simplify. So in the first fraction, let me rewrite the numerator as it is, 2 to the power of 2x divided by, so in the denominator I can expand the exponent, so therefore I'll get 2 to the power 5 to the power of 2x and plus 2. Plus 5 to the power of x divided by 2 to the power of x times 2. Now let me continue. So in the first fraction, I can express it to the power of 2x divided by 5 to the power of 2x times 5 squared, and plus, let me rewrite the second fraction as it is, 5 to the power of x divided by 2 to the power of x times 2. Now I can continue. So here I can use the following formula to simplify further. So we know that a to the power of n divided by b to the power of n is always equal to a over b to the power of n. Now using this, I can continue to simplify the last two fractions. So therefore in the first fraction, we see that here I can apply our formula to these two for denominator and numerator. So as you can see, I can express it 2 over 5 to the power of 2x and times 1 over 25, and plus, so for the second one, again this formula, so therefore I'll get 5 over 2 to the power of x and times 1 over 2. And let me here express the last two fractions as follow. So 5 over 2, let me show another formula. So we know that a over b to the power of n, so I can here, to make this n negative power, I can here replace this a and b, so b will be in the numerator and a in the denominator, and to the power of minus n. So therefore using this, I can express the last two fractions as, so 5 over 2 to the power of minus 2x and times 1 over 25 and plus, so here let me rewrite as it is the second fraction, 5 over 2x to the power of x and times 1 over 2. Now here I'll get from the original fraction the following fraction after rearranging. So f of x is equal to, so 5 over 2 to the power of minus 2x times 1 over 25 and plus 5 over 2x times, 5 over 2 to the power of x and times 1 over 2. Now, as you remember, we are looking for the value of the following fraction. So here, following function. So here, let me rewrite this expression here as it is. So f of, we are looking for 1 over 1 minus logarithm of 10 over 4. So it means that here we have to now, this is the question, let here x is equal to 1 over 1 minus logarithm of 10 over 4. Now I can simplify the right hand side of this identity. So let me continue here, 1 over, so I can here express logarithm this one as logarithm of 10 over 10 minus logarithm of 10 over 4. And as you can see here, I can use the following formula to simplify further this logarithm. So we know that logarithm of a over b minus logarithm of a over c is always equal to, as you can see, bases are the same, then logarithm of a over b over c. Now using this formula, I can easily now continue to simplify this fraction. So therefore, in the denominator, we see that bases are the same here. So therefore, logarithm of 10 over 4, and this is equivalent to 1 over logarithm of 10 over 5 over 2. Now, let me apply the second formula for the last fraction. So we know that logarithm of a over b is always equal to 1 over logarithm of b over a. Then I can apply this logarithm, so this formula. So therefore, from the last fraction, we will get simply logarithm of 5 over 2 and over 10. So it means that x is equal to, so let me write here, x is equal to logarithm of 5 over 2 over 10. And that means that we have to find the value of f of logarithm of 5 over 2 over 10 is equal to, as you remember, after rearranging, we got this function. So therefore here we can easily plug into our function. So therefore 1 over 25 times, so 5 over 2 to the power of, so here minus 2 times, so logarithm of 5 over 2 over 10 and plus 1 over 2 times, as you remember in the second one is this. So therefore here 5 over 2 to the power of simply logarithm of 5 over 2 over 10. Now it's easy to simplify. So here I'm going to use the following formulas. So we know that logarithm of, so here a times logarithm of, let me here, b over c. Then to eliminate this a, this goes to the exponent of this c. So therefore logarithm of b over c to the power of a. So the second formula is, so here a to the power of logarithm of a over b. Then as you can see, bases are the same, so therefore this one is equal to simply b. Now using these formulas, we can easily simplify the first logarithm. As you can see, now we have to eliminate this minus 2. This minus 2 goes to the power of this 10. So therefore 1 over 25 times, so here 5 over 2 to the power of logarithm of 5 over 2 over 10 to the power of minus 2 plus, so here 1 over 2 times 5 over 2 to the power of logarithm of 5 over 2 over 10. And as you can see, we can now use the second formula. So therefore this is going to be simply 10 to the power of minus 2, and this is simply 10. So therefore here this is going to be equivalent to 1 over 25 times 10 to the power of minus 2 is 1 over 100, and plus here 1 over 2 times simply 10. So therefore this is going to be equivalent to 1 over 2500 plus 5, and this is going to be equivalent to, so this one is 2500 and this one is 7501. So this is our final answer. Thank you for watching. Please comment and subscribe to my YouTube channel.